Today we are in Croatia and we are standing now next to one of the main viaducts, Carevdar Viaduct, of this amazing railway project in Croatia, connecting Croatia to Hungary. Today I'm also accompanied by two engineers. On my right side is Mr. Emre Yolal from a construction company Cengiz in Sad. Hello, Mr. Yolal. And on my left side is Mr. Krešimir Ilić, chief designer from Radionica Mostova from Zagreb, Croatia. I would like to ask you some questions, and first of all, thank you, Mr. Yolal, for facilitating this opportunity and having us here on your beautiful construction site next to this viaduct. I would like to ask you some questions. Maybe the first one would be to tell us more about your company in general. Thank you.
Cengiz Construction is a leading infrastructure company. We work in different countries and different regions. Turkey, Bosnia, Slovenia, Azerbaijan, Bulgaria, and Middle East, are some of them. We are generally focused on transportation and water management projects. We already completed about 2,000 kilometers of roads, 1,000 kilometers of railways, about 800 viaducts, 300 tunnels, and 15,000 hectometer capacity of storage capacity of dams and etc. We are in top 250 international contractors list of ENR since 2006. We have a challenging and a nice team. Let's say we're trying to continue our work with a high quality.
Can you tell us something more about this specific project? It's a huge project, and we are only next to one of viaducts. Exactly. So can you tell us more?
Yeah, this project is started at the end of 2020. Actually, it's a double-line railway project. It's 42 kilometers double line. And actually we are renewing one line and constructing a new line. It's increasing the capacity of transportation of this region a lot. It contains a lot of major structures like Carevdar Viaduct and Komari Viaduct, totaling, let's say, 1 kilometer. And also, we can mention about Lepevina 1 and Lepevina 2 cut and cover tunnels. These are also about 900 meters. We already completed more than 16 overpasses and underpasses. In the project we have 3 major railway stations and 6 railway stops. And also I think we should mention about Drava Bridge, which is a 4,000 ton ILM methodology constructed, let's say, steel bridge.
Yeah. So when do you expect to have this project finished?
We are targeting to finish the project totally at the end of 2025. We are at the 60% right now. But the major structures are more or less completed. So now we are much more focused on the alignment.
Okay. When you are mentioning major structures, maybe this could be one of the challenges you had, this big viaduct.
Yeah, of course. Actually, every day is a challenge in this project. But if we need to specify some major challenges, especially the design of the Carevdar, design optimization of Carevdar and Komari viaducts, starting from foundation to deck. Moreover, the Drava Bridge, design optimization, they were big challenges. We studied with numerous experts on this manner, and at the end we achieved. As a construction, yes, again the Carevdar's U-shaped deck was really a challenge.
But we are standing at the moment,
we are at the moment over here. Most probably our designer will mention more about these challenges, but it was a challenge. Moreover, this Drava Bridge, ILM, and well foundation works, they were also challenges.
Yes, but you managed to finish all.
We have the remaining details right now. Let's say, hopefully these major structures are completed.
And then we come for the opening. Exactly. To see how this looks like.
I would like to thank Mr. Ilić here, because he managed to, show all details us, and actually we didn't have any unknown during the construction.
Great collaboration.
Yeah, it was great.
Thank you. You must be also proud on your team and on your colleagues.
Exactly.
Thank you for being with us today.
Thank you.
So on my left side, as I said before, Mr. Krešimir Ilić from Radionica Mostova in Zagreb, Croatia, as a chief designer. Hello, Mr. Ilić. Nice to have you here.
Thank you.
And you must be also very proud seeing your project come to life.
Of course, we are very proud to see our designs come to life. we are now standing beside an almost completed and complex structure, which is part of a future line from city of Rijeka, port of Rijeka and Adriatic coast to Zagreb. And we have this section to be connected with Budapest in neighboring Hungary. In the future, the passenger trains will greatly reduce time distances between major cities, and also freight trains will greatly improve placement of goods further into Central Europe.
Great. And can you tell us a bit more about other structures that are involved or included in this project?
Of course. In overall, we have two viaducts, two semi-integral railway viaducts. We have a large steel truss bridge over the river Drava. We have 3 cut and cover tunnels. We have also numerous small structures in alignment, smaller bridges, underpasses, culverts. We have 8 pedestrian underpasses in stations connecting all the platforms with the stations. We have 3 cut and cover tunnels and 6 overpasses.
Okay, that's a lot of work was for you, also for design, as we heard also from Mr. Yolal, as well as for construction company. But were there any specific challenges that you would like to highlight, something from the design side?
Of course, we had plenty of challenges on a project of this scale. Organization-wise, the challenge was that we have the existing line, which has smaller radiuses, geometrical characteristics than newly designed tracks. And partially we make new tracks, double track lines, and partially we work beside the existing line, which is under traffic. Of course, it brought challenges for organization part of the job and also for designing, engineering part.
Absolutely. Okay, and we are here now next to the Carevdar viaduct. We can mention few facts about it, maybe?
Of course.
The main ones.
It is a 600 meter long structure. It comprises of a few typical, let's say, integral parts, dilatations. And here, where we stand now, is the junction of the future motorway, which will go below the structure. And it imposed our disposition of piers and spans, of course.
Okay, and really now to focus on this part, because this bridge has different sections. This is a section where we stand, next to it is a U-bulked U section. So maybe tell us, here we heard from you before that there are some interesting pre-stressing details have been done.
Of course, we had, let's say, engineering challenge, design challenge here, because elevation lines were preset for the railway and for the motorway, and we didn't have enough place below the tracks to place typical cross-section of a typical, let's say, railway structure. So we had to adopt, let's say, unique solution with the 2 main girders above the track.
Okay, so you have both longitudinal and transversal pre-stressing here. This is something that...
The whole structure is, in total, is longitudinally pre-stressed, but also this part here is longitudinally and transversally pre-stressed. It's a statical system of grillage.
Yes, okay. So we will hear later more about this specific detail and this part of the Carevdar viaduct from your colleague later. And I want to thank you for being us today, both. Thank you, Mr. Yolal. I believe you need to return to work.
Yeah, thank you for coming once more.
For us. Yes, and thank you, Mr. Ilić, and we see each other later. And now we are standing also on Carevdar viaduct, but from the different corner. We are now on the top of the U-shaped section. And therefore, I have here someone with me. This is Rahela Mikulic from Radionica Mostova, a designer of this part of the bridge and many other structures along this railway project. Hi, Rahela. Nice to have you here. I would like to ask you some questions. We were talking before with Mr. Ilić about pre-stressing, very specific, interesting, challenging for you. Can you tell us a bit more how you dealt with that one in your design?
Yes, well, pre-stressing is a complex part of any bridge designing, and in this case, Allplan bridge was very helpful because we get very detailed. We get a model the tendons in a very detailed manner, because each of the tendons has its own curvature, so it has been most helpful.
Okay, also for longitudinal pre-stressing
yes,
that you have together.
Of course.
And how you did the construction phase is also something that you mentioned could be interesting for our audience to hear.
Yes, well, construction phases has been good because it has been aligned with formwork phases as well, and it has been prerogative to keep site engineers very clear on what pre-stressing on each phase would be. So we can model anything in Allplan Bridge, but it has to be very clear for site engineers to implement that.
Yes, exactly. Like Mr. Yolal before mentioned, it's challenging, sometimes even more for a construction company. Okay, thank you. And exactly taking this into account, having longitudinal and longitudinal and transversal panels, together with the soft reinforcement, which was a lot here, as you told us before. Can you tell me how did you manage the collisions, and was that a bit of critical part for you, and how Allplan supported you in this part?
Well, collision check has never been easier with Allplan and Allplan Bridge. As you can see, this is very big,
massive
cross section to even engineer. So to use Allplan has been most helpful to us, because as you can see, we have longitudinal cables, cross cables. We have very thick reinforcement. So collision has been very good for us.
And very challenging, but you managed to finish. Okay, thank you, Rahela. We will also be able to see some of the models and construction site implementation. I believe that was also then not so complicated when you had the perfect drawings to deliver.
Yes,
okay.
Of course.
Thank you for being here at this section, but we will see each other also later in the other part of the interview. And now again I am joined by Mr. Ilić, the chief designer from Radionica Mostova, and we are standing this time next to the other great viaduct, and this is Komari Viaduct, which is also part of this transportation project as the next part after Caravdar Viaduct. Hello, Mr. Ilić.
Hello.
Once again. Can you tell us a bit more detailed information about this project?
Of course. This structure is 365 meters long. It is divided in 3 sections with 110 meters each.
Okay, and we can see a large number of piers here. Are there some specific details important? So what is, for example, the height and how many piers there are?
Well, we have 14 piers here in total, from 17 to 28 meters in height.
Okay. What were your considerations when you were modeling and designing those piers?
Well, except of course for supporting the superstructures, we had to adopt for the underslung MSS technology and formwork.
Which is the erection method you use here.
Yes,
we will talk about this a bit later in some details. Okay, and how did the Allplan Bridge help you with this modeling here specifically?
Well, we use here pier templates. We found that it was speeding us so much on this structure with these 14 piers, but also on other structure where we have many other piers. It was great speeding and it was much easier for us to use
so
pier
more
templates.
effective and faster
Yes,
workflow at the end. Okay, thank you. So repetitive elements and using templates, that would be your comment.
Yes,
okay.
the project we have many piers and it was seeable, visible, helpful to use templates.
Okay, thank you. So we see now, after the model is done, this impressive structure behind us with a lot of supporting elements. Thank you for now. We will see each other later. And now we are still at the Komari Viaduct, but coming closer to the pier section. And I have again with me here Ms. Rahela Mikulic from Radionica Mostova. And she will tell us a bit more about this specific element that we want to comment. So, hello, Rahela.
Hello.
And I would like to ask you to tell us a bit more about erection method that was used, that Mr. Ilić before also mentioned, and also what then specific challenges and demands were necessary for these elements in regard to the erection method.
So for this and Caravdar Viaduct, we used MSS method or movable scaffolding system. In this concrete case, it has been 65 meters long and around 500 tons heavy. So it's very heavy construction to build a bridge like this. We have holes here specifically built for MSS because it is supported on them with brackets. So every hole, one bracket. And MSS in total has 6 brackets for it to be able to move forward and build spans and so forth.
So these holes were also modeled using Allplan bridge.
Allplan bridge, yes. We use these holes because they had to be from concrete distance from the bridge deck, even though the piers are varying in height. So Allplan bridge has been very helpful in this regard.
In this detailing.
Yes.
And we can also assume that reinforcement must be very demanding in these areas around the holes.
Especially just around the holes, we have 3 types of special reinforcement just for the holes. That go around in horizontal and vertical direction, because this part of the bridge is most tensed, most tons is on it, so it has to withhold. And also in Allplan, we designed this reinforcement in such a great detail because the bars are bending, and it was great for collision check regard in other
elements and
other
reinforcement going
Yeah.
vertically and
Yes,
okay. So collision check again helped here as well. Thank you. Okay, thank you, Rahela. It was nice to talk to you, and thank you for leading us through the project and showing us how features of Allplan and Allplan Bridge are helping in your daily work. Thank you very much.
Thank you.
Welcome back to Croatia. We are here again on the site in front of the small underpass Lepavina 1, giving the access for the bigger one, Lepavina 2. I'm joined again with the designers, Mr. Ilić and Mrs. Ilić. Hello again.
Hello.
And given the fact that there are infrastructure projects here, we saw also before, they are quite complex, quite demanding. We need to think about many details, starting from drainage, but also then we go to the reinforcement and the construction phases. A lot of things that must be considered. And the structures, as we can see, this one here now, are not really regular. Mr. Ilić, can you tell us more about this structure here?
Of course, the structure is integral frame with solid slabs. The length is 100 meters and the wall and slab thickness is 100 centimeters.
Okay, and how did you manage the challenges on doing this project?
Well, this structure is in the place of a state road, which is diverted now during the construction of the underpass. Later it will be diverted back on the structure. We had construction and earthing phases. One-sided earthing fields embankment, both-sided, and it imposed some restrictions to the phases of the structure.
Okay, okay, and now the modeling has been done by using Allplan bridge, I guess.
Yes.
And when the modeling is done, there might be some requirements for changes, for iterations in your design. And how did you manage to do that?
All is done in 3D, so it was easier for site engineers to comprehend some ideas. We had some challenges and limitations due to traffic, earthwork, so we had to design in phases to be able to achieve everything what we wanted.
And what is exactly challenging about detailing the reinforcement?
Well, these concrete elements are highly reinforced with many rebars and rebar overlaps, but also a rubber dilatation joint were complex because we had to ensure water tightness because this structure is in groundwater level.
Okay, okay, thank you. Thank you very much once again. Here was nice to talk to you in front of this small underpass and telling us about other complexities which maybe we don't think about when designing infrastructure projects. See you then later again with some other interesting details. And now you join us for the last time here in Croatia at the entrance of the Lepavina 1 tunnel. Again, I have here beside me Mrs. Ivana Ilic, designer, and also Mr. Krešimir Ilić as a designer of this project. We have some questions for you again.
Okay.
Nice to have you here. Thank you for your time
Welcome.
again. And we have some questions for you regarding this impressive structure. First of all, it would be nice to know some more details, like for example, what is the length and other things.
The length of this vast structure is 880 meters. It has a cross-section, typical cross-section of 15 meters, and at the end, in vicinity of Lepavina station, it widens to accommodate 6 tracks, widening to 38 meters.
Okay, impressive. And we are standing next to these massive retaining walls. It would be nice to know about the soil conditions, and also how did you manage detailing and design of those retaining walls? What were the challenges?
These retaining walls have variable height. They are modeled to accommodate the existing terrain, and also they are designed to accommodate other parts of the structure. Drainage, we have longitudinal piping, transversal piping, gully, earthing, catenary posts, etc.
Yeah, there are a lot more details than we think about, also that are incorporated in the design and modeling as well. For example, the protecting and pedestrian barriers, also one of the details.
We have many openings in these structures, therefore we have many pedestrian and protective fences, also around all the catenary poles.
Yes, and speaking of catenary poles, also Ivana, maybe you can tell us how did you incorporate those elements?
Well, yes, all catenary poles are anchored to the structure with details around openings.
Yes, and you mentioned anchors, so anchors and reinforcement details were also
yes,
taken into
we
account.
tried then to pay attention to details like local reinforcement, earthing lines, bolt anchors, so that our colleagues would have less problems later.
On the construction
Yes,
site
on the
as
site,
well.
yes.
Great. And for the last question, I kept the one, can you tell us maybe how Allplan supported you in the project overall? For example, this for the tunnel here.
Well, yes, Allplan helped us a lot because we cooperate with other engineers like mechanical engineer, electrical engineers. So it helped us and helped them to visualize and understand the part of our job.
Yes, and also helped you for collaboration, I
Yes,
believe.
of course, for collaboration and to have a product that is suitable for investor.
Okay, thank you. Once again, thank you for your time. Thank you for giving us the opportunity to visit this beautiful project and showing us how you used our tools, our digital tools for your projects. It was really precious time for us here. Thank you very much.
You're welcome.